Hello everyone, welcome to today's video session. In this session, we will be dive into some fascinating data science case studies with you. We'll take a close look at each case study one by one. I am sure you will find this video helpful and informative. Let's get started. Hello everyone. Today I am going to discuss about case studies in data science and we discuss about how to create a case study and a step-by-step explanation. Here, we create a case study using the topics, diseases, symptoms, and treatments. Creating a case study, first of all, we upload the data sets using this method, upload method. And then we add the title name of this case study. Here, this dataset contains two CSV files. First one is symptom.csv, second one is data.csv. Here, this dataset provides a comprehensive collection of information essential for medical research, diagnosis, and treatment plan. It includes structured data on various diseases, their associated symptoms, severity levels, and recommended treatments based on medical guidelines and expert knowledge. Here, this dataset contains several codes, names, symptoms, treatments, etc. And here it contains also the diseases like itching, skin rash, nodal skin, sneezing, shivering chills, joint pain, stomach pain, acidity, ulcer, and etc. Firstly, we give a brief introduction about this dataset, and then we import the key libraries using NumPy, Pandas, OS, Matplotlib, Seaborn, etc. And then we read the dataset using this function and also we check the shape of the datasets. Here, df1 is dataset 1 and df2 is dataset 2. Here, and next, we check the basic data view or explanation. Here, we find the information of this dataset using .info of. After finding this information, we could understand one missing value exists in the first dataset. That is third one, treatments. Here, one missing value is exists. And then we check the data types of these sets. And then we use .header function to display the first five rows of this dataset. First and second. And then we displays the sample of 10 rows of these datasets using sample of 10 function. And then we displays the column names of the dataset using columns function. Here, the first dataset contains the column names for name, symptoms, treatments, and the second dataset contains itching, skin rash, nodal skin, and stomach pain, acidity, ulcer, and etc. The next step, we check the data pre-processing for clean. Here, the missing value handling is required, and we drop the unbundled files. The drop unbundled files is here. This is the unbundled files, unnamed for 133. Here, this is the unbundled files. So we drop these unbundled files using the drop function. After dropping the unbundled files, and we displays there is no unnamed 133. So it removed here because here unnamed 133 prints. After dropping here there is no unnamed 133. So it removed. And then the next step is removing the missing value. That is missing value. And here we drop the duplicates in the first data set and drop duplicate second data set. And we will use df1.result of sum dot here to check the missing values. That is the treatments, but there's only one missing value exists in this data set. In the data set one, in the second data set, there is no missing value displayed. So we check the missing values. That is, we print the numbers, that is 0, 1, and we print the column names. Here, this function to check the missing value exists in the data set 1. That is, treatments exist only in the missing value 1. In these here, observations are where we solve the missing value using treatment dot filler of one name, comma, in place equal to true. Here, this is the function to solve the missing values. After this, there is no missing value exists. There is no missing value exists. Here, 400, there is all numbers are 400. There is no missing value exists. And then we find the descriptive statistics using these functions. We calculate the mean, median, standard deviation, severity levels, analyze the distribution of symptoms and diseases. Here we find the common means, and then minimum, maximum, STD, Q1, Q2, Q3, and etc. The step 5, we find the EDA, that is explorative data analysis. We conduct explorative data analysis to understand the dataset's structure and identify key patterns and correlations. Here, we create histoplot, X value is symptoms, and then next we create counterplots. Here the X value is symptoms, and next we create counterplots. Here the X value is treatments. Here we create histogram. First histogram is data set 1, and second histogram displays data set 2, DF2 and DF1. This is DF1, this is DF2. Here, finally, we create a histogram using the DF1, that is data set 1, symptoms and treatments. And then we create a scatter plot of symptoms versus treatments. Here we find the differences between symptoms and treatments using this scatter plot. Here the X value is symptoms and the Y value is treatments. In this dataset, we could find the diseases, symptoms, treatments, and here I am going to create another case study using the topic insurance claims for detection. First of all, we upload a dataset named insurance claim for detection using this upload method, and then we give the title name about this dataset. Here, this dataset contains 3 CSV files. First one is employee.csv, second one is insurance.csv, third one is vendor.csv. Here, first of all, we give a brief introduction about this dataset. Here, insurance claims for detection is a crucial area for insurers to manage as fraudulent claims can lead to significant financial losses and operational inefficiencies. Here's an expression of the typical case studies involving insurance claims for detection. Here the company collects a variety of data related to insurance claims, including claims details, customer information, certain claim data, external data. Here's step one. We import the key libraries using NumPy, Pandas, OS, Matplotlib, Seaborn, and etc. And then this dataset contains employee data. That is, this is the master data of the employee working on the insurance claims. The second, vendor data. This is the master data of the vendor who assists insurance company in investigating the claims. Third one, claim data. That is, this is the claim level transactions details submitting by customers to the insurance company for any reimbursement. In the step two, we read the data set using this function, using this period underscore CSV, which is the data set name. And we check the shape of the data sets also. Here, insurance TF1 is data set 1, insurance TF2 is data set 2, insurance TF3 is data set 3. Here, the first data set shape is 1200, then second data set shape is 10,038. Third data set shape is 600,7. And next, that is step 3, basic data view or exploration. Here we explore the data types of this data set using these .dtypes functions. These are the data types: object, integer, floating point, fields. And then we print the 10 samples of each data set using this plot sample of function. This is first data set sample. This is second data set sample. This is third data set sample. And we find the information of this data set using this .info function. This is first data set information, second data set information, third data set information. After finding this information, we could understand that here there are so many missing values existing in this data set. In the first data set, missing value existing address line 2, city. The second data set, missing value existing address line 2, city, customer education language, other contacted city, vendor ID, etc. The third data set, missing value existing address line 2, city. These are the missing values existing in this data sets. And then next, we bring the first 5 rows of this data set using this header function. First, second data set, third data set. 5 rows and 5 columns. And then we find descriptive statistics using this descriptive function. We calculate here, we will calculate mean, median, standard deviation, severity levels, and analysis. This is counted mean, standard deviation, minimum, maximum, Q1, Q2, Q3. So this is first data set. This is second data set. This is third data set. We have very clearly placed this in using this function representation. Step 4, data pre-processing or cleaning. Here, first of all, we bring the column names of this data set using this column of function. First, second, and third. First data set includes agent ID, agent name, date of joining, address, line, line, etc. Second data set column names are transaction ID, customer ID, city, state, risk recommendation, etc. The data set column names are vendor ID, vendor name, address, line, postal code, city, and etc. Here, we drop the duplicate files of this data set using this drop duplicate function. Here, we check the missing values in this data set using this function. Insurance refund is null of sum of. Here, the first data set missing value is existing 2. Here, second data set missing value existing 1, 2, 3, 4, 5, 6. And then third data set missing value existing only two. One, two. Here, given the list of this dataset, this dataset using this function and the column name is also. Here using this function, we check the missing values and its column names. Here, first dataset missing values are 1021 and 7. And the names of column names are present to and sit. Here, the next step, the missing value can be. Here, we solve missing values using this function. After this, we get all values are equal. Here, using this function to solve the missing values. After this, we check there is no missing value exists. Here, all turn to 0. And then we find the information of this first data set. Here, your values are equal 1200. There is no missing value exists. The second data set, if we solve the missing values using these functions. Here, first of all, we find the missing list of missing values. Here, the 6 values, no values exist, and we find the column names. These are the missing values exist. Here, using this function, we solve the missing values. After checking the missing value, there is a missing value exists. Here, all numbers are equal. Product 10,000. There is no missing value exists. And we solve the third data set missing value. Here, there is two missing values exist. 503 and 6. These are column names. We find missing values using this function. Here, that is sent to CG 503 and 6. Using this unknown function to solve the missing values, the data set 3. Here, we find the information of this third data set. Here, all numbers are equal. There is some missing value exists. Roll out 6 numbers. And next, we find the unique values of this dataset using this unique post method. These are the unique numbers of this dataset. This is first dataset. This is second dataset. This is third dataset. In step 5, that is EDA, exploratory data analysis. Here, we conduct exploratory data analysis to understand the dataset structure and identity, key patterns, and correlations. Here, we first create a count plot. Here, the X value is inserted in the state. In the first data set, second data set, we count the incident states. The next, using the count plot, here X value is incident hours of the day. The second data set, here we count and X is incident hours of the day. And next, we create a histogram. Here the X value is agent ID, the Y value is vendor ID. In the second data set, we find differences between agent ID and vendor ID using this histogram. In this case study, we check employee data, insurance data, and vendor data. And we are step by step guide into solving the use cases in this dataset. That is first one, data preparation, second one, claim level fraud detection, third one, employee fraud detection, fourth one, employee vendor detection, fifth one, implementation and monitoring. Here, we create another case study using the topic that is urban mobility and traffic patterns in smart cities. In this case study, first of all, we upload a data set using this upload method, and then when you create a title layer about this data set using this dataset includes only one CSV file, that is Urban Mobility Data fastlayer.csv. Here, first of all, we give a brief introduction about this dataset. Here, we explore urban mobility and traffic patterns in smart cities. Involves a rich amount of factors. First one, First one, that is traffic patterns and congestions. Here the peak house, congestion for sports, and etc. Second one, weather impact, that is temperature of traffic, weather related traffic patterns. And third one, road types and efficiency, this road hierarchy, smart traffic management, and etc. Fourth one, vehicle trends, that is electric or automatic vehicles, shared mobility, and etc. Fifth one, population effects, this urban density and migration patterns. And the step one, we import the key libraries here using is NumPy, Pandas, OS, Matplotlib, and the Seaboard, etc. These dataset contains timestamp, congestion level, weather condition or rainy, cloudy, near, road types, that is city, street, highway, residential, and vehicle types, that is car, bus, bicycle, and temperature, humidity, wind speed, perceptions, and populations. In step two, we read the dataset using this function, that is pd.read underscore csv and the dataset's name. And we check the shape of this dataset. That is here, 32,903 and 10. In step 3, we check the basic data view or exploration. Here, we using this .info function to find the informations of this dataset. Here, after this, checking this information, we could understand that here there is no missing value in a system because here is all values are equal or same. And then we check these d types to check the data types of these data sets. Here these are concepts, floating point, projected, etc. And using these header function to print the first 5 rows of this data set. And then using this sample of 10 to print the sample of 10 this data set, 10 cells. And this columns function to print the column names, that is the timestamp, position levels, weather condition, road types, vehicle types, temperature, humidity, wind speed, perceptions, population density, and etc. These are the step 4, the data pre-processing or clean. Here, there is no missing value access in this data set. So the cleaning is not necessary. Here, we drop the duplicate files using this function. And then this is the long.substitute function to print or check the set names. And then we find the discrete statistics. Here we calculate mean, median, mode, and standard deviation of several levels, analyze urban mobility and traffic patterns in cities. Here using these functions. This dot describe of function. Here, let's count the mean, standard deviation, minimum, Q1, Q2, Q3, maximum, etc. And the next step, step 5, that is EDA, and that is exploratory data analysis. Here, we conduct exploring data analysis, analyze EDA to understand the data set structure and identify the key patterns and correlations. Here we use the bar graph or bar plot, check the vehicle types and count. That is axis vehicle types and here is count. That is the vehicle types are bicycle, bus, car, and etc. Next, we check the weather conditions using the bar graph. Weather conditions are cloudy, clear, rain, etc. And then using the histograph to check the weather conditions. That is Here, these are frequency. And the last one, we create scatter plot of road types versus vehicle types. Road types that is city street, highway, residential, and vehicle types are car, bus, bicycle. So here is vehicle types. If even higher road types, city street, residential. At last, creating this case study, we check the urban mobility and traffic patterns in smart cities, and we explore traffic, weather, road types, and vehicle trends, etc.